Hey everybody, welcome back to this channel. In this video, I just want to go over how to use LTSpice for power measurements and for phase measurements. So I'm going to share my screen here. Right, we've got LTSpice open to a blank schematic. I'm going to put down a voltage source, and we're just going to look at this series RLC topology, right? The harmonic oscillator that we looked at a few weeks ago. Input resistor, inductor, and capacitor. Right, and I'm going to wire everything up. So here's our circuit. Everything is in series. I'm going to label my nodes. And I'm going to right click this voltage source, and we're going to be looking at alternating current. So I'm going to go to advanced here. And we're going to do a sine wave. No offset. We'll set the amplitude to 1 volt. And this is a peak amplitude, I believe. And we'll set this to 100 hertz. Set the resistor to 10, the inductor to 1 millihenry, and the capacitor to 1 microfarad. Cool. So, I mean, these are just all arbitrary values. I'm just showing you an example of how to run this. So let's do a transient analysis. We'll run from 0 to 100 milliseconds. I'm going to run this. Actually, I'll label my nodes first. So up here, we have the input voltage. I'm going to label that node in. And over here on the right is the output voltage, right? The kind of voltage that we're interested in looking at here. I run that, got my scope, and going to plot the input voltage and the output voltage. And it looks like they're right on top of each other, but there is some phase delay. And in order to look at that phase delay, we're going to zoom in. And to zoom in, you left click and kind of just drag. You know, some of you have done it on accident. But what the easiest thing to do is probably to zoom in around this 0 crossing, right? So I'm going to go just above it and just below it, and just keep on zooming in until we hit that 0 crossing. And we're going to figure out here what our phase delay is. So I'm going to get one cursor here on the input voltage, and then I'm going to get another cursor onto the output voltage. So this one is on the input. I'll drag that back there, and I believe that's the same one. So here's the one on the output. It's tracing that output voltage, right? So let me drag this one, and we can see we've got a phase delay of about 100 kilohertz here. So that's how we would go about measuring the phase response. Another thing that we'll need to do is look at the magnitude response. And to do so, right, we just zoom back out, and we want to look at these peaks, right? We want to look at the transfer here. And these are awfully close, so we'll just call this, like, you know, it's 1-to-1, right? You don't necessarily need to measure it. This is very clearly V in is equal to V out, more or less. So, but then for other frequencies, you know, it will be different. So let's try 1,000 hertz. We've got 1 kilohertz here. And another thing to notice here, right? So you can kind of vaguely see that, well, we'll just zoom in here. You can see that here, the voltage is leveled out. This is what we refer to as steady state, right? So in the beginning, we have some what we call transient response, right? So where it's not, it's still the sinusoidal input is still kind of having some impact on the circuit, hasn't leveled out yet. But here, we've reached steady state. So, right, we don't want to measure this, the peaks here. We want to look at when we're in steady state. And one more thing, another thing that we're looking for is whether or not the input is lagging the output, or the output is lagging the input. And to do so, right, we just go in somewhat early, right, once we reach steady state here, and we just take a look at this waveform, and you can see, right, the input is reaching a maximum before the output, right? So we can say that the output, right, so time is going from left to right, and we say that the output voltage is lagging behind the input. So you'll get to play around and see what lagging and leading happens when we look at inductors and capacitors by themselves. So the last thing that we're going to be doing is looking at power. So I'm just going to delete these. And to plot power, right, so we have this little arrow. When we want to measure current, we've got like a little probe when we're measuring voltage. But if you click Option on Mac or Control on Windows, not Control, Alt on Windows, it'll bring up this little thermometer, right? And this will measure your power. So if I click on this, right, it's plotting the output, right? So the voltage across this guy times the current going through it, right? And you can do this for any device. Look at the power through this inductor, right? And it's right, so the voltage here is going to be the difference from here to here, right? Which is why it shows this differential voltage. But the current is just IL1. So I'm going to delete that for now. And we'll just take a look at this. So again, here's like a little bit of a transient happening in the voltage waveform. But we're more interested in the current, or sorry, not the current, the steady state response. So we're looking for the average power, right? So instantaneous power you can find by just dragging this and looking at any instance of time. But average power, we want to look at a particular period, like one period. So to look at the average power of any kind of like thing that you have on this plot, you just Control left click, and it shows you the average power between 5 milliseconds and 21 milliseconds. But what we really want to do is zoom into a single period and measure the average power, right? So you Control left click, and it'll give you the average power. And so it's 677 microwatts, which is effectively 0. So that's that's to get the average power through this capacitor, right? So it's pretty much 0. If we wanted to get the resistor average power, we would do Option on Mac or Alt on Windows, left click this, and you can see that the resistor does have some power here. So if we Control click this, oh, actually it's relatively small there as well. But anyways, I think that covers just about everything that we want to talk about here. So thanks for tuning in. See you guys next time.